How should a charge q be split between two objects placed d units apart to maximize the force between them? So basically we are looking at two charges. Two charges. They are conveniently placed far away. Now we have in total q, that is here say a and here it will be q minus a. So if here we have a coulomb, this will be q minus a coulomb. So this is how the charges are distributed. Now the question is, how should this be? What should be the value of a and q minus a should be so that this two will experience the maximum force that is possible. I already given a clue, but let me ask it in another way. So first thing is first, we know that by Coulomb's law, we have the force given by k times of q1, q2 by r square. So on substituting, what do we get? The constant in place of q, say we have q minus a into a by r square. In this case, it's d square. Now, how do we go over doing it? How can we find the maximum? We have to make use of differentiation, right? We have to make use of differentiation, second order differentiation, first order differentiation, so on and so forth. So I'm going to make use of differentiation. So if you guys are not familiar with that topic, second order differentiation is nothing but derivative of derivative. I'll just show that. Forget about all of that. Very basic question to you guys is, what is changing over here? What can we change over here? See, we had to find a point wherein things are maximum. So what is that we have in our hand? Obviously, constant is constant, that we can't touch, right? And what else? So this is the we can't touch. Distance is fixed. Then what else is fixed? This is also fixed. All these are fixed. Is it not? So what is the only thing that we have in hand? A. So differentiating with respect to what? A. That's the only thing that we can differentiate with respect to that is. Because everything else, it will be constant. So df by dA, k by d square, we'll take it out. And we have to differentiate q minus a into a with respect to a. Now, what does this look like? This looks like, yes, product rule. K by d square. So here it would be q minus a plus of minus 1 into a. So this is basically k by d square q minus 2a. Right? Again, all this has to do with your maths. So now it's not the place to explain. It's just a simple matter of differentiation. Now we are going to differentiate with respect to a again. This is known as second order derivative test. So this is df by dA, right? So we are just differentiating this again. So this topic makes things a lot convenient. So I don't have time to explain in detail over here, but it's nothing but we are differentiating it again. That's it. So k d square and differentiating q minus 2a with respect to a, as simple as that. Q is a constant, minus 2a differentiation will give us k d square minus 2 into a by dA, that is 1. So basically this is minus 2k. Again, this is to do with differentiation. I can't go in detail. So minus 2k by d square. From this, it implies that wherever this point is, right, whatever the 0 is over here, that's the point of maximum, right? So on solving, this is known as second order derivative test. So that you guys will learn in time if you're not learned. So basically we need to solve for this particular expression. So here clearly this will go to 0 and q minus 2a. So a is equal to, we are solving for a, q by 2. It makes sense, right? Q by 2 into q by 2 will be the maximum possible scenario wherein the product, this particular product is maximum. The common sense tells that q1, q2 has to be maximum while the distance is fixed because k is constant. So q1, q2 and r are the only variables. So r is also fixed in this case. So it has to be dependent on q1, q2. When will this product be maximum? When they are half and half, that is equal basically, q by 2 and q by 2. So how should a charge be split? So we'll conclude that. So thus we need to divide the charges into 2 equal half. And that's your answer. Again, this has to do with second order derivative test. So this is a point of, as per second order derivative test, this implies it's point of maximum. Again, I might sound a bit weird over here because there are a lot of math happening. I'm not explaining the concept. If you see our second order derivative maximum and minimum topic, you will understand this particular question. So let me put it this way again. We are trying to figure out what is the point at which q1 and q2 will be maximum given q is fixed. That is, the entire charge between those two objects is fixed. We'll start off by assuming that let the charge be on the first object be a and the second object will be q minus a, right? And the force formula is given by k times of q minus a divided by d square into a. Here k, q, the capital Q and d square are fixed. So obviously a is the only thing that we can handle. So we are able to differentiate with respect to a, right? That's what basically differentiation does. It will plot the force and a, right? With the change of value of a, how the force will vary. So the faster way of looking at this graph is to differentiate it. So this gives the expression of behavior of force with respect to a. Again, this is all technical. If you are good with maths, this will make sense. If not, I can't help you with this, as of now at least. You guys have to go back to the basics. So there's something called a second order differentiation, second order derivative test or something like that. So basically we are differentiating the same thing again and we get a negative answer over here. So this implies that it's a point of maximum, that is this point. So on solving, which is that we are solving, on solving, I need to specify what is that we are solving. 1 being this. Okay, my bad, I kind of jumped to that point. So we'll get a is equal to q by 2. And thus we need to divide the charge into 2 equal half is our conclusion.